In these video series we are going to talk about operating system. This video clip will introduce to you the basic concepts in operating system. Like what is operating system, what are the main parts of an operating system, the common types of operating system and how does an operating system work. An operating system is the core software that allows a computer to run as a useful device. It manages the hardware, the user interface and all other software running on the computer. Without an operating system, a computer is just a collection of components heating up the room as no one would be able to make any practical use of the machine. Types of operating system. These are some of the most widely used types of operating system: simple batch system, multi-programming batch system, multiprocessor system, distributed operating system and real-time operating system. Simple batch systems. The simple batch type of system has no direct interaction between user and the computer. The user has to submit a job, written on cards or tape, to a computer operator. Then computer operator places a batch of several jobs on an input device. Jobs are batched together by type of languages and requirement. Then a special program, the monitor, manages the execution of each program in the batch. The monitor is always in the main memory and available for execution. Multi-programming batch systems. In this the operating system picks and begins to execute one job from memory. Once this job needs an input-output operation, operating system switches to another job. CPU and OS are always busy. Jobs in the memory are always less than the number of jobs on disk, or job pool. If several jobs are ready to run at the same time, then system chooses which one to run, CPU scheduling. In non-multi-programmed system, there are moments when CPU sits idle and does not do any work. While in multi-programming system, CPU will never be idle and keeps on processing. While time-sharing systems are very similar to multi-programming batch systems. In fact, time-sharing systems are an extension of multi-programming systems. In time-sharing systems the prime focus is on minimizing the response time, while in multi-programming the prime focus is to maximize the CPU usage. Multiprocessor systems. A multiprocessor system consists of several processors that share a common physical memory. Multiprocessor system provides higher computing power and speed. In multiprocessor system all processors operate under single operating system. Multiplicity of the processors and how they do act together are transparent to the others. Distributed operating systems. The motivation behind developing distributed operating systems is the availability of powerful and inexpensive microprocessors and advances in communication technology. These advancements in technology have made it possible to design and develop distributed systems comprising of many computers that are interconnected by communication networks. The main benefit of distributed systems is its low price or performance ratio. Real-time operating system. It is defined as an operating system known to give maximum time for each of the critical operations that it performs, like OS calls and interrupt handling. The operating system which guarantees the maximum time for these operations are commonly referred to as real-time, while operating systems that can only guarantee a maximum of the time are referred to as soft real-time. Parts of an operating system. The operating system can be broken down into four main parts, namely kernel, device drivers, user interface, and system utilities. First is kernel. The kernel is the main component of most computer operating systems. It is a bridge between applications and the actual data processing done at the hardware device, such as computer printer would not be able to work with the computer. Then, the device drivers. Device drivers is a group of files that enable one or more hardware devices to communicate with the computer's operating system. Without drivers, a hardware device such as a computer printer would not be able to work with the computer. The user interface. User interface is the part of the operating system is directing what you see on the screen. This is the portion of a software program or hardware device that is used to navigate and control aspects of the program or hardware device. System utilities. System utilities is the part of the operating system provides all the basic facilities that run in the background without user interaction. This is important to manage the memory, to manage the input and output devices, to provide platform for interaction between computer and user, and to manage the communication between devices. Basics of how operating systems work. Interrupts are signals sent to the CPU by external devices, I/O devices. They tell the CPU to stop its current activities and execute the appropriate part of the operating system. There are three types of interrupts. First is hardware interrupts are generated by hardware devices to signal that they need some attention from the OS. Second is, software interrupts are generated by programs when they want to request a system call to be performed by the operating system. Last is, traps, which are generated by the CPU itself to indicate that some error or condition occurred for which assistance from the operating system is needed. Interrupts are important because they give the user better control over the computer. Without interrupts, a user may have to wait for a given application to have a higher priority over the CPU to be ran. This ensures that the CPU will deal with the process immediately. CPU execution mode. There are two modes of execution, known as user mode and kernel or supervisor mode. User mode is restricted in that certain instructions cannot be executed, certain registers cannot be accessed, and I/O devices cannot be accessed. Kernel mode has none of these restrictions. A system call will set the CPU to kernel mode, as will traps and interrupts. Application programs cannot do this. Mode bit. The supervisor mode can execute all machine instructions, and can reference all memory locations. While the user mode can only execute a subset of instructions, and can only reference a subset of memory locations. CPU response to interrupts. The CPU performs the following actions in response to an interrupt. 1. Using the pointer to the current process control block, the state, and all register values for the process are saved for use when the process is later restarted. 2. The CPU mode bit is switched to supervisory mode. 3. Using the pointer to the interrupt handler table and the interrupt vector, the location of the kernel code to execute is determined. The interrupt vector is the IRQ for hardware interrupts, read from an interrupt controller register, and an argument to the interrupt assembly language instruction for software interrupts. 4. Processing is switched to the appropriate portion of the kernel. The CPU uses a table and the interrupt vector to find OS the code to execute in response to interrupts. As the computer runs, processing switches between user processes and the operating system as hardware and software interrupts are received.